enjoy the chat. We also have some people over in Facebook and YouTube land, so hello and welcome everyone. Hey Eric, nice to see you over there in YouTube. Andy, C. Grover, Ken, Gary Z, Andy Calloway, hello, hello, hello. All right, so the next thing I'll say is if you want to check out the product pick of the week in advance and go to the product pick page, get yourself a discount. It's going to be 50% off during the live stream. That's the QR code. This right here is the URL. You can head right there and watch the show from inside the product page. It has a discount for you and this live stream embedded all right within. In fact, I'm gonna refresh the page myself and check. Yes, in fact, it is now half off. So go there. But I'm getting ahead of myself. Let's actually have Limor tell us a little bit about what this product pick of the week is.
Okay, it's the LTR390. It's a UV sensor. This is the last I2C UV sensor available. We've carried many I2C UV sensors in our times. Our favorites from the Vemel 6070 to, I don't even remember the ones before that. There was like an MC8511 or something. But they all got discontinued. UV sensors seem to not last very long in this world. However, this one is available. This is a true UV sensor. Unlike some sensors that say they are UV, this one actually has a UV diode inside of it. It is tuned to 300 to 350 nanometers, which is about UVA. So what does that mean? It's good for telling if you're about to get sunburned. It's not great for telling if your UV disinfection lamp is working well. It will totally pick up some of that signal, right? It's better than nothing, but it's not really designed for that. It's designed for basically, health monitors that you wear that tell you, hey, you've got too much sun exposure. That said, it's a really lovely little sensor. It's very easy to use. I2C has an interrupt pin. It also does ambient light. And we've got code for it in Arduino and CircuitPython. So if you'd like to do some UV light sensing, pick up one of these breakouts, plug and play. You can plug it into your CyberDeck.
All right, and so before I talk about it, let me run over to my cabinet of wonders and pick one up for myself. Yes, that's right. The product pick of the week this week is the LTR390. It's a UV and ambient light sensor. Mine's kind of glommed onto a bunch of stuff right now. It is a UV and UVA and ambient light sensor, and it's in convenient Stemma QT form factor, which is how I have it wired up here. So let's talk about this a little bit, and then I'll show you a little demo. So the sensor, if we jump over to the product page here, you can see, take a look there. Look at that. It is half off right now. It's $2.48. You can pick up to 10 of them, depending on the big plans you have. And here's the deal with this. This is a true UV diode that is designed to measure the 300 to 350 nanometer wavelength. It also has a second diode for ambient light. So you can use the ambient light sensor for typical ambient light things like, did I hold my phone up to my face? That's what a manufacturer likes that kind of thing for. But the UV sensing, since it's true UVA in that wavelength range that it's measuring, this is really useful for determining if it's safe to be outside in the sun for human skin. So skin aging, skin cancer, all of these things are related to the UVA light in particular. And this gives us readings. It gives us digital readings in what's known as a UV count that you can use to correlate the UV index. So the UV index, as you may know, gives us a range of 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That was the original range. And then as the ozone layer got depleted over time, scientists had to come up with 11 plus. So when you get to that 11 plus range, things are super dangerous. But you can go and you can look up a forecast for your local area, but with this sensor we can get direct readings. And one reason this is nice is that UVA readings are influenced by your altitude as well as your cloud cover. So while you can look at a forecast, that's going to be very generalized to an area, such as the city you're in, but with this you can pinpoint it right down to one little spot, one little 2 millimeter by 2 millimeter spot, and know exactly what the UV count is. So let me show you, let me fire up this demo and we can take a look at this in action. So I'm going to switch over to this down camera here. And you can see what I've got. I've taken one of our lovely little friends, the Raspberry Pi Pico, the Stemma QT to pin cable is used here so that I can go to an OLED screen and then another little Stemma QT cable over to our sensors. That's the LTR390 right there. What I'll do is I've got a battery pack here. I'm going to fire that up because I wanted this to be mobile. And you can see there I've got a little readout, and this is telling me right now the LTR UV sensor has a UV read right now of 1. So that's just some UV light, some very small, tiny, throw it away. This is 0 basically as far as the index goes. So in this room right now I'm not being hit by UV light. We also have the little ambient light sensor, and you can see this is going to decrease as I put my finger over it. And I wrote some code that will store the maximum just so I can go outside, get a reading, and then come back here and read it. Before I do that, I'm going to actually take a little UV LED. So this is one that we sell in the store. This is a little UV LED, and as you see, when I hold this over the sensor, I'm getting a read of about 14, 15, 16 at the maximum here, 18. If I, by contrast, if I remove that LED and just take a green one, put that in there instead, I just have this sort of notched into one of our little battery packs. So there you go, there's a green LED. Look at that UV reading at the top there. Nothing. So the green LED basically has no UV. If I grab a red LED, we're going to definitely get some, I've noticed. From this red LED, we get reading of about 4, 3, 4. So that's a decent little example of it working. But now watch this. What I'm going to do is I'm going to run right out my workshop real quick and hold this up to the sunlight. I think we've got direct sun right now. There's no clouds. This is Southern California, so prepare to be amazed. Hold on one second. You should still be able to hear me. So I'm just going to hold this up to the sky and let it get a little maximum reading here of, okay, we're at about 126. So let's see. So what we've determined is, what does that mean? What is 126 in terms of the UV index going to tell us? Let me look at my notes here. And in fact, I want to thank Lady Ada and Carter Nelson and C. Grover, all of whom helped me figure out from the data sheet how we might be able to correlate this to a value. And in this case, we think that at the gain setting and the bit depth that this is at right now, which is a gain of 3, bit depth of 16, a count of 95 is one index level on the UV index. So if I do, what did I say I have right now? 126 divided by, what did I say, 95. That should be a UV count of about 1.3. I looked at, now depending on the cloud cover this could change, but I looked at the forecast for my city and that correlates. The forecasts are accurate to plus or minus 1 index. So that gives you an idea. You may have other uses for this, but if you're interested in using this to really determine, is it safe to be outside? How long can you be out? Do you need to get some suntan lotion on or a shirt or a hat or something like that? The tools are definitely there to do this. And in fact, if I show you what the code looks like, let's hop over here for a moment. And I'm going to go to my Atom. So this is a modification I did to some of the sample code that runs. I just added a display to it and that maximum value variable that we can store. So here you can see we set up the I2C bus and then we create the sensor object here, LTR390. And I'm going to skip all the way down to the part that matters here, down at the bottom. Let me zoom in so you can see this. All we need to do is ask for this LTR.UVS, that's the UV sensor, and that returns to us a count, a digital number. So there's a analog to digital converter built right onto the sensor, so it does that conversion for you, and then it spits out a digital value, in this case 16-bit value. So you can also check the ambient light just by asking LTR.light. And then there's also some provisions inside of the way the chip works and in the Circuit Python library that allow you to do things like set thresholds as well as adjust the gain and adjust the gain and bit depth. So depending on your needs, you may want to fool around with those, but in the defaults, a gain of 3, bit depth of 16, and the factor of the conversion is basically a count of 95 as one index level on UV. It's been a bit of a treasure hunt to try to figure this out. I'll show you the data sheet here where some of this information is available. So this is the Lighton LTR390 UV. It gives us a little info about it. It says things like identifying UV index and ambient light helps people to effectively protect themselves from sunburns, cancer, or eye damage. So it gives you an idea of why you might use it. And then as we look at the formula for conversion, what you'll see, we're almost there. Bear with me. I'm going to find you. Look for a big formula. Did I pass it? I hope not. I'll keep going. There, it's, okay, that's the Lux conversion, and this is the conversion factor here. Can I zoom in on that? I might be able to. Yes, good. So here what you'll see is, depending on the gain, it shows you the different factor. There's also a factor for, I mentioned cloud cover, there's also a factor for glass. Depending on the window glass, some window glass will have some UV protection. So there's a lot of things you need to figure out. I even found you can take some UV protective sunglasses and put it in front of it and sort of test different sunglasses to see which ones are blocking more UV light. But this is the chart, this is the conversion. It's the sensor count, which is that number we're getting divided by a sensitivity of, I believe it's 2800, and then multiplied by the factor depending on your gain and your bit depth. So all the tools are there for you, and we'd love to see if anyone is able to create their own little UV index routine in here. It'd be really cool, maybe something to add to the library. It's all open source, it's CircuitPython. We also have drivers available for Arduino as well. But that is it. So let me know if anyone has any thoughts, comments, questions over in the chat. I'll check out the YouTube chat. Oh yeah, Eric Osterly mentions you can suggest you need more sun for vitamin D. So yeah, I have the perspective of a Southern Californian that, my gosh, the sun is trying to kill us. But depending on where you live, you may want to use something like this to determine if you're getting enough sunlight, enough vitamin D. So good point, thank you. And Ken Santema said, I thought of using this for testing a UV lamp for resin printing, but it won't go up to the UV range needed to test a UV lamp in resin printing. It would be 400 nanometer wavelength. Yeah, so the UVA, B, and C are used for different things. C is I think the one that's used for decontamination. This isn't going to test that, as Lady Ada mentioned. So I think that is it. Yeah, Wahoo007 says, very nifty, would like to maybe add this to a weather station. Yeah, it would be a great addition to a weather station. Just create some weatherproofing for it and put it in a case that's see-through without any UV blocking, and there you go. And I think that's going to do. Oh, Todd says if you use these LCD shutters with a UV sensor, you can make peril-sensitive sunglasses where it'll drop the UV shades for you when the UV is beyond a threshold, which is great. And I think they even make windows with this LCD blocker built into it. Eric B. Wirtz says, fancy zebra headers. Yeah, so on this Pico, I put some white headers and painted sloppily a little bit where the power and ground are, just so I could kind of keep those straight. It helps you figure out where to plug things in. Let's see, is that it? Have we hit it all? I think that's it. So a reminder, if you want to go and pick one of these up, head on over to this product page, which is product 4831. You can go to this URL right here, Adafruit. I'm pointing at it down there, adafruit.com/product/4831, or point a camera at that QR code, and it's 50% off right now. So you can grab some of those to play around with. Why not? And be sure to pick up some STEMMA QT cables too along the way so that you'll be able to plug those into your devices. All right, I think that's going to do it. So, in conclusion, hey, there's too many of me there. Go away. There we go. That is my product pick of the week. It's the LTR390, and it is a UV and ambient light sensor breakout board in Stemma QT format. And I'm not going to peel this off of this project because I'm still using it, so I'm just going to turn it off and hang that whole thing from my Stemma QT board of goodness there. And that's going to do it for JP's product pick of the week. I will see you next time. Thanks, everyone. Bye-bye.